A very good afternoon to one and all. I am Dr. Pallavi Patil, Assistant Professor in Pharmaceutical Chemistry Department from Modern College of Pharmacy, Nigri. And today we will continue the same topic, chromatographic separations. This is the 8th lecture, and in these lectures you will feel that the separation is optimized for the illusion of the first two components. Now, whatever the component get isolated from each other by the liquid chromatographic separations, the last two components is a long retention, because the long whatever the compositions they are retained on the stationary phase goes long way, but their retention should be long whenever the last compositions. The mobile phase is optimized in the illusion of the last two compounds will be unfortunately give the result badly. Why? Because they give the early illusions. In the last figure we have seen the two composition out of 6 get the immediately illusions. It means that they have a very less contaminated contact with the stationary phase, and the illusions get easily find out. The two compositions are co-eluted, that is the second one, but that the separation is not happening in the right way, so that was also a bad separations. So in this concept we will see later on. Now this is a good peak, whatever you see. Now in this, the broadening of this peak is a high, and this is also a somehow, but it is a immediately start, and the result we will see. And the next one is having a better resolution as compared to this. So with this effect you will see that this is the broadening is the least and a sharp peak, as well as the peak area is defined. You can centralize the value, as well as you can find out your retention factor, then height, peak width, band broadening, and the diffusion and factors also on the various calculations. But here the symmetric of telling and fronting factor is somehow confusing. So this is a main difference, as well as the retention time should be more than at least a 2. It's from here to up to the end of, it's a good for the retention time and the resolution and the separation of the chromatography technique. So this is, you can also optimize the separation of the middle two compound. Now this is by adjusting with this and this is good. This is also a completely fine, because maybe it depend on the concentration is a low, and this is the very good concentration as well as good peak area, and the resolution is also good. But in this way this is also fine and this is also fine, but this is not completely accepted. In case the composition of a mobile phase, you have to need to think about that and change the fundamental certain factors and parameters whenever you are going to run the chromatographic techniques. Now the optimization of separamize with these two is adjacent with these two is fine. Okay, with these continuations we will see how the chromatographic gets separated fully all components except double resolutions. It is not acceptable to optimize a single compound only if the compound has a more than 5 to 6 elements, and you have to define on the chromatographic the separations by the chromatographical peak. This is a definitely shown on your site, on your chromatograph. Whatever the problems we have achieved, the consequences of this optimization of the individual is definitely separate, because individually composition is different, individually structure is different, and how that structure of composition compound is reacted with the stationary phase is different, and mobile phase composition is also a different during the separation technique. So you need the single component in your mixture of the compound should be very defined and specifically designed in such a way it has a prominently retention factor with resolution from the each other. Okay. Now this is not actually relevant to our subject, but just I want to share something how the effect of this electrophoresis buffer. We need a electrophoresis buffer, because whatever I have told you ki there are different type of compositions in a mixtures, and each compositions having a defined structure as well as their reactive pattern to the mobile phase and the stationary phase. Now whatever the component is present in that, if it is a supported a buffer to maintaining their ionization, to maintaining their pH level, to maintaining their pK value, so it is a better to get the component react with the mobile phase as well as the stationary phase, and your illusion of your component get separate. And this is also important for those who are created some more affinity towards the stationary phase. Means your component, if you have six component individually have a different chemistry with the stationary phase and with the mobile phase. So the chemistry should be a match. They have a certain long retention time. We just increase the long retention time in the component with the stationary phase, not the mobile phase. If the chemistry is very good in the mobile phase, so definitely it will run faster through the column. But we don't want that. We want to, the retention time is more, the chemistry in between, the interaction between the solute and the stationary phase is happen, and later on it goes to till the detector. So in this way, this is your sample injection technique. This is your mobile phase running systems toward the detector. This is an amplifier which is having a giving the voltage and the polarity check, whatever the ground stage of the polarity and what type of the polarity you need to adjust it as per the requirement of your solute, as per requirement of solvent, mobile phase and your stationary phase. So this is a total plan design, and this is totally automatic systems. You just need to adjust your pH value, and how the pH value is get adjusted, it depend on the what type of sample you have selected and what type of mobile phase you have selected. Okay, and this is injected your samples and it goes, and detectors will few, and this is a totally final the data acquisition. The data acquisitions means you will get a direct your spectra, you will get your direct chromatogram, and this chromatogram is defined with the total chemistry of buffer, how the buffer is interacted with this solute as well as your component and your solvent systems. Okay, so with this, now first, the mobile phase composition should be suitable for the separation of the first elution compound. Yes, the mobile phase is definitely. Now you feel that the mobile phase you need to change. There is a second option for the second component separation. You can change the mobile phase. It depend on the what type of the detector you feel, what type of the chromatographic technique you use. Isocratic chromatography and gradient chromatography. So you have to adjust it in that way. The different type where the mobile phase composition you change, there is a gradient type of illusion we said. And if you don't change, once you start your chromatography and end of the chromatography, you can't change your mobile phase, so we call it as isocratical mobile phase. So there are different changes in the formula. We say that how the composition of different type of solvents we get together and finalize the mobile phase. But before the finalizing mobile phase, the composition you are concerned is linear, parabolic and stepwise, and whatever finalize you have to check the pH, because you need to get interacted whatever the further you are designing to check out the buffer systems. So this is the retention time. So with this retention time, we will see these are the 6 type of the composition. Now you feel that whenever you are looking for the first slide, your first two, this two is just designed to get here, and the second one is come for the here steps, and the third one group, that is a D and E. His probably came here. So in this way you are just confusing which one is the good. So I told you this one first group is also not accepted because it's less than the 2. This one is having a certain less separation and not define exactly close to the 1 or 2 resolution power. So this is not acceptable. So third one is also the end of this, but the resolution is somehow greater. So in this composition we are selected. Now the parameters, whatever the parameters you define to get change the chromatography in such a way कि resolution, your band broadening, your height, then your peak area and your concentration, as well as very important what type of mobile phase you are selecting, what type of stationary phase composition. And the stationary phase composition means what type of the column you are selected, is polar, non-polar, what type of the systems, isocratical or gradient. Then what type of the phase you are using, reverse phase or normal phase, as well as the parameter that we have designed means what K, distribution constant, then CS is concentration in the solution of stationary phase and the mobile phase, then retention time in the mobile phase, then retention time of analyte in the stationary phase, then length of column, then velocity of solute in the mobile phase, then velocity of a mobile phase, then selective factors, then diffusion of solute in mobile phase, diffusion coefficient of solute in stationary phase, thickness, then multiple path effects, longitudinal diffusion, okay, as well as the velocity is average linear velocity, multiple path factors, and important thing is resolution and retention time. The retention time, whatever these are data acquisitions, means these steps you realize these all factors as goes in the right way, and you just find out the retention time, and the whatever the data will comes on your computerized systems, you just recognize the data and calculate your all equations and fundamentally statistically data, and just justify to your whatever the results come with your calculations. So this is called as optimization, the best chromatographic technique with a multi-component mixtures. Now this is a multi-component mixture. This is 1 2 3 4 5 6. Okay, so this is a very good in the peak area, broadening, height, as well as the retention time. So this is a acceptable. Okay, so we will stop here with the thank you very much for listening.